Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the lectures on computer vision. In the last lectures in CNN, we saw how we can actually prepare our dataset for CNN and in what format our dataset should actually be in. In this current lecture, we'll actually have a look at model preparation phase. So we actually left at the point where we were told to point out specific directories using Kira so that we could actually train our train our model using the images. So we'll be doing that and then we will be preparing our model in this lecture only. So without wasting much of our time on this, let's get started. So what I'll be doing is I will open up my Jupyter notebook over here, and I have imported all of the required libraries. And now for pointing out to specific directories, what you would be required to import is from keras.image, keras.preprocessing.image import, and then you do have to import a thing which is known as image data generator like this, and then I would actually create the image data generator object, which is idg is equals to image data generator. And then now using this particular image data generator, I would actually point out to the specific directories. So the specific directory to point out is, I will store this in a variable known as training data equals to idg dot flow from directory. You have one function which is known as flow from directory, and here I would specify the directory name, and the directory name should be actually tomato slash, let me just check what the directory name is, tomato slash val. So tomato slash val is the name of my training directory, and then I'm required to pass in a parameter which is known as target size, which is actually 64,64. Like I'm giving it a target size of 64,64, and then I'm required to pass in a class mode which is known like class mode, which is basically categorical, and this is what parameters I'm actually required to pass in over here. And then I have another directory known as validation data. Again, I would be using the same thing over here, idg dot flow from directory, and then tomato dash, okay, this should not be the val, I guess. If I were to go back over here, this is train and this is val. Okay, so this is actually train and this is actually val. And then target size, same target size is equals to 64,64, and then class mode is equals to categorical. And then we do have to specify the batch shape as well. So not batch shape, actually batch as well in both of these, that is a training data set and in the validation data set as well. So I will give batch size is equal to 32 and batch size is equal to 32 here as well. And then I would run this piece of code for you. So as you can see, it tells me that in the training dataset it has found 10,000 images belonging to 10 classes, and in the validation directory it has actually found out 1,000 images belonging to 10 different classes. So we would be training our model on the training dataset and validating it on our validation data. So now we have to prepare our model. So let's say now here I would actually import different libraries that is required for preparing our model. So first I would import sequential from keras.models, and then keras.layers import star. So from keras.models import sequential, and from keras.layers import star. So since CNN is a sequential model, we need to import the sequential first, and this layers which would actually import everything right from activation energy to max pool 2D and all of those kind of things. So I will run this piece of code for you, and now we will be preparing our model. So model is equal to sequential, and then I have to do model.add conf2d. So I hope you remember what are the parameters in conf2d. The first thing is the number of filters. The second thing is the filter size. So I'm giving it a filter size of 3,3. Then you have to give in the input shape as well, because it's the very first layer. So 64,64,3, and then you have to give activation, which is basically ReLU in our case, right? So you remember all of these parameters and the mathematics behind it. And then what I'm doing is I will be adding a max pool 2D layer to actually get the maximum value from the convolved matrix that we have got. So max pool 2D, and then pool size is, let's say, 2 comma 2, and then I'll be adding the dropout feature using model.dropout is equals to 0.25, right? And I will copy this over here and paste it over here. Basically what I'll be doing is I'll be changing the number of filters and removing the input shape. So removing the input shape and changing the number of filters, let's say it's 64, and then it's, let's say, 128, and then let's say it's 256 as well. It's 256 here as well. Okay, it's 256, and just let me delete this input shape from here as well. And this is how our model actually looks like. At the very first thing, we have a 32 filters, each having a filter size of 3 cross 3, which will be randomly initialized, and this filter will actually convolve over the whole image, that is traverse over the whole image, and give you a corresponding convolved matrix or a traverse matrix. And then in the traverse matrix, in a pool size of 2 comma 2, we'll be finding out the maximum value, and then we'll be storing it, and then we'll be randomly dropping some about 25% neurons. The same thing, then 64 filters, 128 filters, and 256 filters, which we are gradually increasing. And now what we have to do is we have to flatten our model, because we want to like, it's a 2D model and we want to get our prediction in 1D format. So we have to flatten our model, and now we have to add in one dense layer. So I will be adding the dense layer over here, which is, let's say, dense, and in dense, let me just pass, like, let's say 32, and activation is equals to ReLU. And then in the last dense layer, which is our final prediction layer, I would just add model.add dense, the number of classes, which is 10, and then activation is equals to softmax, right? So I hope you remember all of these different kinds of activation function, like when we use ReLU, when we use softmax, and when we use sigmoid, everything of, like, everything here. So I will just run this piece of code for you, and this model has been successfully, like, run for me. And now I will, like, let you know what the model summary is. So this is the model summary that we are getting. And now I hope you actually remember how do we get the output shape. So we have an image of size 64 cross 64, and we were actually, like, using a 3 cross 3 filter. So the number of shapes, that output shape that we get is n minus f plus 1. So 64 minus 3 is 61, plus 1 is 62. So 62 cross 62, and this 32 is, like, the number of batches that we do have. And then we just divided by the number of pool size in, like, the pool size when we are working with max pool 2D layer. So it's 31 cross 31, that is 62 by 2, because the pool size we have used is 2. And this is how you actually get the number of trainable parameters and, like, every mathematics going over here. So I hope you are comfortable at this point in time. So I will meet you in the next lecture where we'll be actually training our model and getting our results. So see you in the next one. Thank you.